Okay, so what we're going to talk about today is absolute value equations and inequalities. And already in this unit, we've talked about solving equations, and we've actually talked about solving inequalities, and we've even included talking about inequalities combined with and or, which is good because we're going to need that in order to be able to understand how to solve absolute value equations and inequalities. So let's start on page 15 of our notes, and we'll do the equations first because the equations and the inequalities work a little bit differently. So what I want you to think about is if we look at example A and we say the absolute value of x equals 3, and I asked you, just use your common sense, what do you think x could be? Raise your hand if you know what x would be. If I say absolute value of x equals 3, what would x be? 3. Okay. Is there anything else that x could be? Negative 3. X could be 3 or negative 3, which is interesting because we don't usually get multiple solutions for an equation. But this can happen with an absolute value equation. So there are actually two answers to this, and that's going to be x equals 3 or x equals negative 3. And that worked out fairly easily because it was a pretty easy problem. But if I gave you the second one that said the absolute value of x plus 3 equals 7, I know right away you could say that x equals 4, right? That makes sense. But what would the other one be? And maybe it's not as easy to see what it would need to be. But what we're going to do is I'm going to show you a method to figure out what the other one is that you can use on any problem, no matter how complicated it is, because you're probably going to have more complicated ones than this. Now, the rules, this is a general rule, if you have the absolute value of, and a capital A represents whatever is in there, doesn't matter what's inside the absolute value, whatever is in there equals B, where B is a positive number, so right down here, B is a positive number, then A, whatever is in the absolute value, equals the positive B, or it equals the negative of B. So would you agree? This inside of here has to equal 7, right? Or if this inside of here equaled negative 7, then the absolute value would also be 7, right? So what we're going to do is set up two equations, and we're going to solve both of those equations. And the way we're going to do that is we're going to say x plus 3 equals 7, or x plus 3 equals negative 7. And now you may have noticed when I wrote both of these equations, I don't have any absolute value bars written. Well, I don't need them written because I am not looking at the absolute value anymore. I'm looking at what's inside and what that has to be. And what's inside either has to be positive 7 or negative 7. So now I don't need those absolute value bars anymore, which is good because we don't know how to solve an equation that has absolute value bars in it. The way to do it is to use a process to get rid of them, and that's what we're doing. So if I subtract 3 on both sides, I get x equals 4. And if I subtract 3 on both sides over here, I get x equals negative 10. And that's how I'm going to get my two answers. If you look at example C, you see absolute value of x plus 8 equals negative 3. And you might be in your mind trying to figure out how you can get x plus 8 to equal negative 3. But it's x plus 8 can equal negative 3. But when you take the absolute value of anything, you know that absolute value is going to be the positive value, right? Absolute value is always positive. Is the absolute value of anything ever going to be a negative number? No, it's never going to be negative. All right, so that's going to bring up an important thing. If the absolute value of any expression equals a negative b, there is no solution. Because no matter what I put in here for x, Once I take the absolute value of the left-hand side, I have a positive number. I can't get a negative number out of absolute value. So this just has no solution. And in case you haven't seen this before, it's a diagonal line through a circle. That is the universal symbol for the empty set, which means there is no solution to this particular equation. Now, I hope it's obvious that if you have absolute value equals 0, you're not going to get two answers because there's no positive 0 and negative 0. There's just 0. So you're just going to get one answer. So what we're going to do is we're going to go through some examples of working these kind of problems. And they're ones that maybe aren't as easy to solve just looking at them. So we're going to use the process. Now here, I have absolute value of 2x minus 1 equals 5, and 5 is a positive number. So we're going to go up here to the rule where we have absolute value equals a positive number, and we're going to write two equations without the absolute value bars. So those two equations are going to be 2x minus 1 equals 5, or 2x minus 1 equals negative 5. All right, and that's going to get us our two answers. So if I add 1 to both sides of this, I have 2x equals 6. Divide both sides by 2, and I get x equals 3. Over here, add 1 to both sides, and I get 2x equals negative 4. Divide both sides by 2, and I get x equals negative 2. So my two answers are 3 and negative 2. I do get two answers out of that. And just like any equation, I can plug them back in to see if it works. So let's go over here to example B. Once again, I have absolute value equals a positive number. Go up to the rule. If I have absolute value equals a positive number, then I'm going to have two equations. And those two equations are going to be 3x plus 2 equals positive 4, or the 3x plus 2 equals negative 4. And let's go ahead and solve those. So I'm going to subtract 2 on both sides, and I get 3x equals 2. Divide both sides by 3, and I get x equals 2/3. Over here, subtract 2 on both sides, and I get 3x equals negative 6. Divide both sides by 3, and I get x equals negative 2. Okay? So that's some pretty simple ones. What we have next in example 2, further on down the page, are ones where we have absolute value, and we have some stuff inside of our absolute value. But if you notice, for example, on the left-hand side of this equation, I have stuff in the absolute value, but I also have stuff outside the absolute value, don't I? I do have stuff outside the absolute value. So what I want to do is I need to get the absolute value part by itself. So what I'm going to do, this is our strategy. Let's write this down, strategy. That is isolate absolute value. And I know that this can be somewhat confusing to do. And you're looking at this going, okay, so do I subtract the 3 to get rid of it? No, look at it like this. If you look at this absolute value equation that we have right here, would you agree it bears some similarity to the equation 3n minus 1 equals 8, right? It bears the resemblance. It has a 3 in front of something, then minus 1 equals 8. Would you agree? It bears the resemblance. And I know you know how to solve this one. You're going to use the same steps that you would use to solve this one to get that absolute value by itself. So, up here, would you subtract 1 first? Of course you would. So right here, subtract 1 first. Or add 1 first. I'm sorry. Add 1. Add 1. So now, bring down what's left. I have 3. Absolute value of x plus 2 equals 9. Now, if you got to the point then over here where you did that, and you would have 3n equals 9, right? And what would you do to get the n by itself? You would divide by 3. Well, you're going to do that same thing right here. You're going to divide by 3, just like this. And these are going to cancel out, and you're going to have absolute value of x plus 2 equals 3. So what you're going to do at this point is go back to the general rule. You have absolute value equals a positive number, so we're going to go up here to absolute value equals a positive number, and you're going to write two equations. So our two equations are x plus 2 equals 3, or x plus 2 equals negative 3. Subtract 2 from both sides, and I have x equals 1. Subtract 2, and I have x equals negative 5. All right? So I want us to do the next one, but I'm not going to write the equation with the n in it. But I want you to think of that absolute value as something you're trying to isolate. So the first thing you're going to do, subtract 3 from both sides. And you have 2 times the absolute value of x plus 9 equals 4. Get rid of the 2 by dividing by 2. I think one of the biggest mistakes I see when students are doing this is they get to this point and subtract the 2. And it's a division situation, really. So we have absolute value of x plus 9 equals 2. Now, the other thing I see students do is go up here at the top and make two equations, one with 7 and one with negative 7. Yeah, you can't do that yet. You can't split it into two equations until you get the absolute value by itself. Once you have it by itself, then you can split it into two equations. So at this point, I can write x plus 9 equals 2, or x plus 9 equals negative 2. Subtract 9 on both sides, and I get x equals negative 7. Subtract 9 over here, x equals negative 11. Now, at the very bottom of the page, I've got a problem that looks a little bit different. We're still going to do it the same way. Do you remember how we just did this, where we said this either equals the positive of this or the negative of this? Well, we're going to do it the same way. So here's what I'm going to write. I have 3x plus 2 equals 4x plus 5, or 3x plus 2 equals negative, and then in parentheses, 4x plus 5. So I'm doing it once with the positive value on the right side and once with the negative value on the right side. So now, on this side, I might subtract 3x from both sides. And I have 2 equals x plus 5. Subtract 5 on both sides, and I get x equals negative 3. Go over here, and we're going to do the same thing. Well, but we're going to have to distribute first. So 3x plus 2 equals negative 4x minus 5 when I distribute. Get all your x's on one side. So maybe I'm going to add 4x to both sides. And that's going to give me 7x plus 2 equals negative 5. Subtract 2 on both sides, and I'm going to have 7x equals negative 7. Divide both sides by 7, and I get x equals negative 1. Might I suggest, when you get to the end of these, let's check and see if they work, all right? So if we check negative 3, 3 times negative 3 is negative 9, right? So negative 9 plus 2 is negative 7, and the absolute value of that, would you agree, is 7. So let's just write that over here on the side. Over here, let's do this. 4 times negative 3 is negative 12. Negative 12 plus 5 is negative 7. So here's what I ended up with when I plugged in that answer. That doesn't work. And that's why it's really important that you check. So I'm going to take this, I'm going to put a little circle around it and put an X through it, because that one doesn't work. Now, there is a name for a solution that you get when you solve a problem that really doesn't work, and the name for it is extraneous. So I'm going to write that here for you, extraneous, extraneous. let's go ahead and we'll try negative 1, see how that works. So 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. Take the absolute value of that, and I get 1. Over here, 4 times negative 1 is negative 4. Negative 4 plus 5 gives me 1. So that one worked, and this one would be your solution. Okay? One more page to go. So let's turn the page and we're going to talk about absolute value inequalities. And these can be a little bit more challenging because you've got a lot of different procedures to remember when you're doing this. So we see up here that I have the absolute value of x is less than or equal to 3. And this conceptually can be a little bit difficult to understand. So here's what I'm going to do with this. I'm going to draw a little number line. And we'll put a 0 here. And 1, 2, 3, 4. Let's do some negative numbers. So there's negative 2, negative 3, and negative 4. Now, here's what I want to do with this. I want us just to think of what positive numbers will work in this inequality. All right? And if you think about what positive numbers would work in this inequality, would you agree that anything from 0 all the way up until 3 and including 3 will work, right? Because these are less than positive 3. Okay. Think about it this way. What negative values, once you take the absolute value, are going to be less than or equal to 3? And would you agree it's everything from 0 all the way down to and including negative 3? And you can see what we have here. Now, based on your homework from the last 2 days, what does this remind you of? Overlapping, and overlapping goes with which word that we, this is an and combined inequality. That's what this is. This is an and combined inequality. And our solution here is negative 3 is less than or equal to x is less than or equal to 3. And when we write our and inequalities, this is the way we write them. So this sets up for us the general rule. If you have absolute value of any expression less than a positive value, you are going to take whatever your expression is and set it in an and inequality between that positive value and its negative, and then you're going to solve, and that's going to give you your answer. All right? So you won't have to combine it in the end. You're just going to go ahead and solve it that way. So what I want to do is go down here to example A in number 4, and we're going to do exactly that. We've got absolute value of 2x minus 1 is less than 5. 5 is our positive number here. So we're going to set it up just like this. So I'm going to put my 2x minus 1 in the middle. I'm going to have a less than and a less than. I'm going to put positive 5 here and my negative 5 here. And what I'm going to do is go ahead and solve this. So add 1 across all 3 parts. And I have negative 4 is less than 2x is less than 6. And I'm going to divide everything by 2. And I get negative 2 is less than x is less than positive 3. And that is my solution to this absolute value inequality. Let's do one more of these, okay? So once again, I've got absolute value less than, what's less than or equal to, still uses the same rule, positive 8. So it's this rule, so I'm going to set it up as an and combined inequality. So the 3x minus 4 goes in the middle. I'm going to have a less than or equal to on both ends. On the right, I'm going to put the 8, and on the left, I'm going to put negative 8. All right? And we're going to add 4 across all 3 parts. So I have negative 4 is less than or equal to 3x is less than or equal to 12, and I'm going to divide everything by 3. And I have negative 4/3 is less than or equal to x is less than or equal to positive 4. Now I need to say this. If you have an equation that also, or an inequality that also has other stuff outside the absolute value, you have to isolate absolute value first before you do this. So you got to isolate absolute value. Has to be done first. So I want you to think about something else. What if we had, and let's do this example over here on the side. What if we had the absolute value of x is less than -3? And I want you to think about this, because once you take an absolute value of any number, you're going to get a positive number, right? And any positive number is going to be less than -3? No, positive numbers aren't less than a negative, they're greater. So this means this isn't going to work, and there is no solution. So this is a no solution situation. So let's go ahead. We've done less than. Let's do greater than. So I'm going to slide this down here so we can get to the examples at the bottom of the page, but we'll move that back up in a minute. I have absolute value of x is greater than or equal to 4. So what I'm going to do is, once again, we're going to look at this in terms of a number line. And put 0, 2, there's 4. Let's give us a 6. -2, -4, -6. Okay, so let me ask you, if I look just at the positive numbers, what values of x will have an absolute value that is greater than or equal to 4? Would you agree it's from here to the right, all these bigger numbers? Okay, so let's have a closed circle here and an arrow to the right. Now, if we look just at negative numbers that will make this work, those larger negative numbers, like -10, -20, those will work, because when we take the absolute value, we get a number that's bigger than positive 4, right? So would you agree it's anything from -4 all the way down to -infinity? And what we have is a graph that looks like this. And what kind of graph is this?
An OR.
This is an OR. Combined inequality. And the way that we would state this answer, can't do it without the word or, is we're going to have x is less than or equal to -4, or x is greater than or equal to 4. And that sets up for us how we're going to solve absolute value inequalities that use greater than. So if we go back up here to the rule, the absolute value inequality greater than a positive value will make us write two inequalities with the word or. One of them will be this exact same thing, but with no absolute value bars right here. The other one, this always ends up getting tricky. There's two things you need to change. You need to make the b negative, and you need to switch the direction of the sign. All right? So we have to do both of those things when we write the second one. So let's go ahead and go down to the bottom of the page, and we'll work on example, the second example A. So this is absolute value greater than or equal to 6. So this is or, I'm going to put it here. And the one on this side, I'm going to do 2x plus 4 greater than or equal to 6. The same as a problem with no absolute value. If you go over here, do the 2x plus 4, and then I have the 6, right? Two things you need to do. Switch the direction of the sign and make the 6 a negative. Both of those things need to happen. Now you have two equations set, or two inequalities set up to solve. So subtract 4 from both sides. I have 2x less than or equal to -10. Divide by 2. X is less than or equal to -5. Go over here. Subtract 4 on both sides, and I have 2x is greater than or equal to 2. Divide both sides by 2, and I have x is greater than or equal to 1. So here's my solution. I don't want to just leave it like this, because I'm not really saying what my solution is. But I'm going to go here, x less than or equal to negative 5, or x greater than or equal to 1. All right? Let's go ahead and we'll do this one. It is also a greater than, so we're going to use this same process. So remember, start with the word or, go over here and write one exactly the same but with a no absolute value. And go over here and we'll get both sides written out, and then I'll write in pink the stuff that has to change. So the stuff that has to change is you're going to flip this to less than, and you're going to make that negative. All right, those two things need to change. Subtract 10 on both sides, so I have 5x is less than negative 25. Divide both sides by 5, and I have x is less than negative 5. Over here, subtract 10 on both sides, and I have 5x is greater than 5. Divide by 5 on both sides, and I have x is greater than 1. My solution, x is less than negative 5, or x is greater than 1. Would you agree, in both of these instances, just imagine what this looks like on a number line, and would you agree that this looks like this? Yeah, and this, it's going to look like this. And would you agree that when you go up here to these ones, this looks like this? So the absolute value less thans are ands. The absolute value greater thans are ors.